a postdoctoral fellow in Hiroshima University in Japan, and I'm very lucky that I get this opportunity to come here to visit for 3 months. And actually, I'm leaving this Thursday, so before I leave, I really appreciate that I have this opportunity to stand here and have a chance to discuss with all of you about my own research. Actually, the main reason for me to come here is to learn from all of you. So this is my final chance, so hope you guys can help me. And because time is limited, so I want to start the talk first. And the topic today is interdisciplinary behavior studies for the cross-sector energy policies. I think there are 2 keywords here. First is interdisciplinary behavior, and another is cross-sector energy policies. This is today's outline. It will include these 4 parts. First, I will briefly introduce the background, and then the research concepts for the energy issues, and then introduce what we have done and we want to do in the future. I think everybody here knows that how serious the energy problem has been in the world, so no need to explain it now. And the energy is always consumed from these 4 sectors. I think in Energy Institute, you always cover all these sectors, but for my research, actually, I only focus on these 2 parts. One is a residential sector, and another is a public transport sector. You can imagine that actually these 2 parts is very related to your everyday life. You need to think how many things you need to use every day in the building, and also whether you need to use a car or how many miles you will drive. These things is very related to your own life. And I call it the household energy consumption. The reason why I focus on these 2 parts is because that we think, for example, for the companies or for the factories, the government can give some regulations to them to ask them to do something or require them not to do something. It's much more easier. But for the household, I think if the government asks you to do this or to do that, nobody will follow, right? So this part is more flexible and diverse than the other 3 sectors. So that's the main reason why I focus on the household part. And there are some statistics to support that why the human behavior is very important, because it do contribute a lot to the energy demand. And for the household energy consumption, we think that it's related with a lot of factors like the house, the end users, people, and the environment, and also it's changed across different life stages. If we look at the energy consumption more specifically, we think it might be an activity-based consumption, because people use the energy so as to satisfy their need to join some activities, like to in-home activities, shopping, working, making this different type of activities. So if we think it in this way, then it might have some time and spatial dimension meaning. So we have a standard model for the consumer decision making for people's energy consumption behavior. It's easy to understand that based on some external influence from the marketing and also from the social and cultural environment, and people try to make some decision by considering their need, their purchase search, and also their evaluations for the different alternatives based on their knowledge and experience. And after that, they will make a decision whether to buy something, if they buy, and how to use it. So that is the output for the energy consumption behavior. And they also, based on their behavior, they have some post-purchase evaluation to which will in turn influence their knowledge and their experience. This actually is a very standard model for the consumer decision making on their energy consumption behavior. But actually, we think that the people's energy consumption behavior is not so independent. We think that, like, if we imagine that the same type of energy consumption behavior, for example, you buy a car. So if you already have a car at home, then now you want to buy a new car. Then in this case, this actually is the same type of energy consumption behavior, right? Buy a car, but happened at different time points, right? So when you want to buy this new car, will you consider the experience from the previous purchase behavior? Will you also consider what the efficiency of the previous car is and how you use that car now? So based on those based on those existing usage behavior, you will consider what you are going to buy for the next car and how you are going to use it. So we think that there might have some interaction between the same energy consumption behavior, which happens at different time points. This is one type. And also we think that for the different energy consumption behavior happens at the same time period. For example, this year you plan to buy a car, and you also want to buy a refrigerator. But because of your money, you can only have enough money to buy the car. So you might think you can delay the purchase decision for the refrigerator until next year. So this is one type of interaction between the different end uses caused by the money budget, right? And if we see another example, look at more short term. Like today, you only have 2 hours free time. So if you spend more time traveling outside, then you can only have less time to spend it at home, to watch your TV, to use your air conditioner, right? So this is one type of interaction caused by the limited time budget. So we think that there might have some interactions between different end uses in different sectors like vehicles and domestic appliances caused by different resource limitations. But the problem now is we don't know what kind of end uses they have this kind of interaction. We don't know this kind of interaction happens within the sector or across different sectors. We also don't know this interaction is one-way interaction or two-way interactions. So all these concerns motivate us to build such kind of integrated household energy consumption behavior system model, which include both the supply side, people's decision-making process, and also their energy consumption behaviors by simultaneously consider the interactions between different sectors or within the sectors. I think now for the Energy Institute, you like the times model, the macro model, you have already did a very good job at the supply side. But in those models, maybe the demand side is not so detailed. And another stream of analysis, I think, in the existing literature, they focus on the process of decision making and also people's demand, their behavior analysis. So there are two streams of analysis now, but still now there is not a good way to can combine them together very well. I think that's still the future research emphasis. But for my research, actually, I also focus on the demand side by looking at the interactions within and between different sectors. So this image is work we want to do, but now we just focus on the demand side. Now I want to introduce what we have done now. The research issue we are targeting is that because traditionally the residential and transport energy consumption are always being separately treated. People analyze the energy use inside building, people analyze vehicle energy consumption. Very few research combine these things together, look at this together. So focus on this research issue, we think that motivated by the existence of the rebound effect and self-selection effects, we think they might have some interaction between them. So in other words, we think the cross-sector analysis might be necessary. Because the rebound effect and the self-selection effects are the main concepts for my research, so I want to give them an explanation first. I think here a lot of people are familiar with this concept, so I just briefly explain it. The rebound effect means an increasing efficiency leads to a feedback in the energy consumption. Two types. One is the time rebound effect caused by the increase in time efficiency. For example, if you buy a dishwasher, then the time you spend on washing dishes can be saved. So the saving time can be used to cook more or can also be used to do some other activities. If this kind of saving time is reallocated from less to more energy consuming activities, then I think the household energy consumption will increase. Another type is an energy rebound effect caused by the increase in the energy efficiency. Assume that you replace your old vehicle by a new, more efficient one. Then the monetary cost per kilometers can be saved. So in this case, the saving money can be used to drive to farther place, or can also be used to watch more TV or enjoy more air conditioner at home. So if this kind of saving money is reallocated from less to more energy consuming end uses, then your energy consumption will increase. So as you can see that this kind of rebound effect, no matter the time or the energy rebound effect, they actually occurs for the whole household energy use. They are not only limited within the residential sector or within the transport sector. It's actually across different sectors. Another is a self-selection effect. I think for this effect, maybe you are not so familiar. Actually, it's like a psychological concept. This effect means it's used to describe the phenomena that some specific factors like people's motivation, attitude, preference, and some social demographics like people's identity. And to describe this kind of specific factors, which make the people self-select them into a specific group, which creates abnormal, undesirable conditions in that group. Give you an example. We take the environmental awareness as an example, and actually a few days ago when I talked with Evelina, she told me that in Switzerland, people, because they are rich, so they actually don't care about money a lot. So they now start to care about the CO2 emission, they care about the energy consumption, right? And they have some mental budget to evaluate how much CO2 emission already be used and also energy use. And if they use more, then they will think, yeah, I already maybe used too much, so I need to save it now. Then they start to save the energy use or save the CO2 emission. So in this case, we actually can explain it as one type of environmental awareness. So for those group of people with high environmental awareness, they might be more possible to choose to use the public transport instead of buying a car or using a car. They might also choose to buy more efficient domestic appliances so as to live an efficient lifestyle and also put an efficient usage on them. So in this case, people buy efficient appliances and people use them efficiently. So these two actually don't have direct relation, but there is a non-causal association between these two parts caused by people's environmental awareness. So we call this kind of non-causal association between these two caused by the environmental awareness. We call it a self-selection effect. You can see that this kind of environmental awareness actually is also an inherent feature of people. It's just the people's attributes. It will not different with their like the vehicle use or like their air conditioner use. It actually covers all aspects of the household's behavior. So if you understand the rebound effect and the self-selection effect, I think now we are easier to understand that this kind of cross-sector analysis between the domestic sector and also the transport sector are more necessary. Okay, after I make clear what's my assumption of the study, now I want to introduce the purpose. Purpose first is to confirm the necessity of this kind of cross-sector analysis, and second is to want to understand the energy consumption pattern from the behavior viewpoint, and third is to develop models and policies to help control and reduce the rising energy use. This is a framework for the following talk, and we think that actually the household energy consumption is related to many household decisions. From the long term, we think that the residential location choice, which can decide their residential environment, their building environment, might interact with the household energy consumption. And from the middle term, we think that the car ownership, the ownership of vehicles, ownership of domestic appliances might be interacted. And from the short term, we think the usage of vehicles, appliances, as well as their decision on the time use have the direct relation with the energy consumption. And actually, all these elements are not independent with each other. They are correlated. So when the technology innovation occurs or the policy is carried out, some of the elements in this circle will change and then cause a change of the household energy consumption. So if we want to understand how to control and reduce the household energy consumption, we must first understand how these things interacted with the energy use, and then we can know how we can change their energy consumption. Actually, later I will introduce this thing with the interaction between this 5 and the household energy consumption. The time allocation part, actually we have done some research about this too, and we developed some models, and based on that model, we tested how the telecommuting policy influence people's energy demand. But here I will not introduce it, so if you have interest, we can discuss it later. But today I will focus on other parts. To support our study, 2 surveys were conducted. One is international energy consumption surveys, which were conducted in 4 mega cities in Asia area. And more than 1,000 samples were collected in each of these cities. This data were used to do some comparative analysis of the energy consumption pattern in different cities with different economy development level. But I will also not introduce it here. Detailed energy consumption information were collected, like the monthly energy use for electricity, gas, gasoline, diesel, those fuels in different seasons. And also the efficiency information and their usage information, as well as detailed characteristics for the domestic appliances and vehicles were collected. We also asked their social demographics and economy attributes. Another survey is the Cauchy panel survey, which was conducted in Beijing in 2010. In addition to the content in the first survey, another 3 contents were added. First is detailed individual attributes, and the second is a residential environment information, and the third is activity, is a time use information, which was used to analyze how the time use behavior interacted with people's energy consumption behavior. And based on this studies, how the times like the flexible working time and also telecommuting, this kind of time use policies, how this kind of time use policies change people's energy consumption demand can be evaluated, but that's not the focus of today. Now, based on those data, I want to introduce how the land use policy and how the technology innovation related to people's energy consumption behavior. First, let's see the land use policy. It is always assumed that there is a one-way direct causal effect between the residential location choice and the household energy consumption, because people think that the location choice decides their built environment, their residential environment, and their residential environment have to form their lifestyle, and their lifestyle then will decide their energy consumption. But actually here another problem is there might be some non-causal association between these two caused by the self-selection effect. Give you an example. If we find a negative relation between the accessibility to the public transport and the household energy consumption, then what the policy implication will be? I think the policy implication will be that we are building a neighborhood by configuring a near bus or subway station, then it can help decrease the aggregate energy demand in this neighborhood, right? Because we find a negative relation between them. So, but here the problem is we don't know how people make their residential location choice decision. We also don't know how they make their decision about their energy behaviors. In reality, some people with high environmental awareness, they might choose to live in the area with good accessibility to the public transport, and they will live an efficient lifestyle on the energy use. While for those people who like driving, who have a very strong preference on driving, they will choose to live maybe far from the public transport stations, and then they will live a car-dependent life. And also for those people with like high identity, like rich people, they think that they are rich, so they will live in some good neighborhoods, and they will use their cars instead of some public transport. So for this kind of people, even if we change the accessibility to the public transport, they will still continue their own decisions, which means this kind of land use policy will not change their decision, actually. So if we don't look at those kind of self-selection effect caused by the environmental awareness, the driving preference, and also their identity influence, then the land use policy effect will definitely be overestimated. So if we want to capture the true effect of the land use policy, then we need to control those parts. So these concerns motivate us to consider to represent the residential choice and household energy consumption behavior simultaneously by explicitly controlling the self-selection effect, so as to capture the true effect of land use policy on the energy consumption behavior. And we built some integrated models. I don't want to introduce it here, it's a little bit complicated. Okay, so the dependent variables included in the model is the energy expenditures on different type of like domestic appliances and also vehicles, and also the savings. We allow people don't use their money, they just save it. And the residential environment attributes, social demographics, and housing characteristics are used as explanatory variables in the model. Here, I only show the result related to the residential environment attributes. You can see that for a lot of residential environment attributes, they have significant influence on the ownership and usage for different appliances and also vehicles. So this result actually shows that the land use policy do have an influence on the energy demand. For this part, I will introduce it later. And now let's see some part related to the self-selection effect. We find for different type of end uses, they have the self-selection effect have different influence on them. We further calculate how this self-selection effect contributes to their energy consumption behavior. And it is shown that the portion causing the self-selection effect actually changes from 2% to 24% in explaining the people's energy consumption behavior. This percentage also is not so substantial, but it do suggest an unnegligible role when evaluating the effect of land use policy on the household energy consumption. So in this case, if we don't control this spurious effect, self-selection effect, the land use policy, of course, will be biased, right? And actually here, another finding can be said. Because the self-selection effect is caused by people's like attitudes, preference, those things, which can be changed by some soft policies like the educational policy or some other soft policies. So based on this percentage, we find that actually for the for air conditioner, for the gas shower, these two type of appliances, self-selection effect actually will influence them a lot. So which means the soft policy might be more useful for these two type of appliances. This actually provide advice for those kind of policy makers about the effect of soft policies. After we control the self-selection effect, we do some scenario analysis and test how the land use policy affect people's energy use. And finally, 7 scenarios were designed by changing the residential environment in the model. You can see that here we do the scenarios like the shopping mall increased by 1 in the neighborhood, and supermarket increased by 1, recreational facilities increased by 10%, and restaurant increased by 10%, and park increased by 1, bus line increased by 1, and train line increased by 1. We assume this type of these 3 scenarios here, and finally we find not all these scenarios play a positive effect on the energy saving. Actually, here only the increase the recreational facilities and the bus lines can help save the energy. So this actually reminds us that when we design the policies, we have to develop some specific methods which can accurately estimate the policy effect. And another finding here is that if we look at this scenario, if we look at this scenario and we only look at the vehicles, you can find that for the vehicle, actually increase the supermarket can help reduce the car energy consumption, right? Because here you can see that in this figure. So if we only look at the vehicle, then we may say this scenario's land use policy is effective. But actually, the saving energy from the vehicle is compensated, is offset by the domestic energy consumptions here. So which makes the total energy consumption actually is increasing. This result actually indicates that if we only look at the transport sector, then the land use policy shows that this policy is effective. But actually, it is a wrong policy. It is not the correct policy which can help reduce the total energy consumption. So if we don't look at the cross-sector effect of the policies, then the result might be biased, might be wrong. So this actually also emphasizes why we need this kind of cross-sector analysis for the energy policies. This is a percentage change, so I don't want to explain it here. After we look at the land use policy, now I want to show you how the technology innovation influence people's energy consumption behavior. When we think the improving technology efficiency is among the most popular strategies to save the energy. And a problem that we cannot avoid it when we look at the technology-oriented policies is the rebound effect, which might partially or fully offset the initial reductions, which is expected to achieve by the technology-oriented policies. So what we want to do here is to calculate how the technology innovation can help save the energy by quantifying the rebound effect. Generally speaking, there are three types of rebound effects, and we are focused on the direct effect, which means the saved money from a specific end use is used to continue the service provided by this end use. And part of the indirect effect, which means the saved money from a specific end use is reallocated to increase the services provided by the existing end uses in the household, while the demand for the purchase of other goods and also the energy involved in the production process is not considered here. So focus on this two, we use some mathematical description to describe the rebound effect. And the most intuitive way to describe the rebound effect is the elasticity of the service demand with respect to the energy efficiency of the end use. And the direct rebound effect can be represented by the O elasticity, which means a relative percentage change for the service demand produced by this end use with respect to a percentage increase of its own efficiency. While the indirect rebound effect can be represented by the cross-elasticity, which means relative percentage change for the service demand, which is produced by this end use, with respect to the percentage increase of the efficiency of another end use. So how others' efficiency change influence my service demand. And also we can use this equation to calculate the total rebound effect. Before we see the result, I want to explain the mechanism here first. If we want to deal with the rebound effect from the behavior viewpoint, then we might deal with four steps. First, ask people whether you have something like a car, whether you have a car, and if you have a car and how you use. Based on your current usage or ownership situation, then we will ask, are you willing to replace your old ones to a new one? Or are you willing to buy a new one? So if they want to buy or if they're willing to replace, then we will ask, which type? Are you willing to buy more efficient one or less efficient one? So here there are a lot of selection problems. Give you two examples. For example, now for a household who use a car very intensively, then they will think I should replace my old car with a more efficient one, then I can save some operating cost. But for some households who actually don't need a car, or who actually just use their car very occasionally, then they will think, I don't need to buy a car, or I don't need to replace to a new one, or even I need to replace, I just buy a less efficient one. Then I can save some upfront cost. So in this case, this kind of selection problems actually exist, which also can be explained as a heterogeneity for different households, for different people. If we want to capture the true rebound effect, then we better include all these 4 steps. But as a price study, we only focus on the first 2. And when we develop the scenario analysis to capture the rebound effect, we assume that all the households will replace their old end uses with a new one. And also we assume the same efficiency improvement rate for different households. So the problem for our result will be that our result can only be regarded as the upper bound for the true rebound effect. This is a model developed to calculate, and let's see the estimation result. Here I only list the result for those end users who might suffering from the rebound effect, which means their efficiency is found significantly related to their energy use. Here first we find that for the air conditioner and the car, we find a negative relation between the efficiency and the end use usage and the air conditioner and the car's usage. This means that the more efficient air conditioners and the cars will result in less money spent on them. So in this case, the efficiency improvement do play an effective role in energy saving. But the problem is we don't know whether the expected saving can be fully achieved. For example, you increase the technology by 100%. The problem we don't know is whether this kind of 100% can be fully achieved. So if this cannot be fully achieved, then that means the direct rebound effect actually occurs. And for the closest water and microwave oven, we find a positive relation between the efficiency and the end-use usage, which means increasing their efficiency actually will make the household more likely to spend more money on it. So in this case, actually, when we increase their efficiency, we cannot get the energy saving. Oppositely, they actually cause additional use on the energy. So this means the direct rebound effect is greater than 100%. That is, the backfire happens. So based on this result, actually it's not so intuitive to see how much is the indirect rebound effect and what's the exact rebound effect. So we further do some prediction and also simulations, which shows the final result of the rebound effect. Here you can see that for the air conditioner, we find that their direct rebound effect is around 60%. It's very large. This actually means that if the technology of air conditioner increased by 100%, then 60% of the expected saving will be taken away. So finally, you can only have 40% saving, energy saving can be achieved. Compared with the direct rebound effect, actually the indirect effect for the other end users is not so large. But if we look at the total rebound effect, you can see that it's actually larger than the direct rebound effect, which means the efficiency improvement of the air conditioner actually do cause additional energy consumption on the other end uses. And we compare with the existing evidence, this result is a little bit larger than the effects for the OECD countries, but similar to the South Korea case. If we see the result for the closest washer, you can see that although the backfire occurs, but it's just around 100%. And the indirect rebound effect is not significantly different from 0%, from 0. Oh. Compare with the existing evidence, which it shows that our result is much larger than the case of the US. Similar with the closest washer's case, for the microwave oven, is also around 100% backfire occur, and also not so significantly different from zero's indirect rebound effect. And still now there is no evidence related to the microwave oven. Let's look at the vehicle's case. For the vehicle, around 34% indirect rebound effect occurs. Compared with the other three cases, their indirect rebound effect is much more significant. From here, you can also see that actually when the efficiency of car change increase, then it do have a lot of influence or the interaction to the other, like the domestic appliances. So he actually also emphasized this kind of cross-sector analysis, emphasized the importance of the cross-sector analysis. And compared with the existing evidence, this result is also larger than the suggested upper bound for the OECD countries. Although this, our result is larger than the existing evidence, but also based on the existing reviews, they mentioned that for the developing countries, the rebound effect might be much larger than the developed countries. So this result is understandable and also acceptable. By controlling the rebound effect, we calculate how the technology innovation works on the energy use part. Here we find that for these four end uses, only improving the efficiency of air conditioners and the cars can reduce the total energy consumption. After you look at the effect, the efficacy of the single policies, then you might think that these two policies, their effect is difficult to achieve our FAR target. Like for UK's case, 80% need to be reduced. And for China's case, 45% need to be reduced. So those single policies is far from that target. Then you might think maybe we need to develop some system to evaluate the package policies effect. So that's what we are going to do here. This is the energy policy system design. Here we also think that the household energy consumption process is not static because of the continuously changing market and the social interaction. So what we are doing here is to develop a dynamic policy system to evaluate the collaborative effects of the policy packages. Based on the self-selection results and also the model structure we used for the technology innovation part, and based on those two things, we